I have here two reactions. One is a halogenation of an alkene, and the other is a halohydrogen formation. So we're going to contrast that and see what is the difference then between these two products. Here, let's say that we're using an organic solvent, such as carbon tetrachloride. And what is important here to remember is that the two reactions start from a, in this case, chloronium intermediate, and this is bromonium intermediate. Well, I'm gonna do something. I'm gonna just say bromonium in the two cases, so I use the same intermediate for both. So if I have bromine, and the first step, what you want to remember when you're doing this problems is that you go through a bromonium intermediate or chloronium. If I had I'm gonna have to change this. I'm gonna redraw it. So let's do the intermediate. In the two reactions, notice the difference is that here we're using water as solvent, and that is in another step going to act as a nucleophile. So both reactions have a common intermediate, either bromonium if you're using bromine or chloronium if you're using chlorine. So, and it's positively charged. Here you had an ethyl group. So you start from this point in both reactions. In this case above, you will have the nucleophilic attack by bromide. Then the nucleophilic attack, where there in this case is going to be water. But in the reaction above, the nucleophile, say, is bromide. In the reaction below, the nucleophile is water. And that attacks after the formation of that intermediate. So for the reaction above, what we need to remember is that the attack will happen at the more substituted carbon, which is this. So here we have a hydrogen, here we have an ethyl. So you will have the attack by bromide here. And then this will open up. And that will give you, important to remember, the two bromine atoms will end up in different sides. So it is anti. The product one bromide is going to be up, say, in a dash, and the other in a dash. But remember that we can also form the bromonium on the opposite side, so we will get also the enantiomer. So what I mean by that is drawing this in dashes, right? So these two configurations will be changed. And again, bromonium intermediate, nucleophilic attack at the more substituted carbon. So let's go and see what happens in the next. Difference again of the two reactions is the nucleophile. You're going through the same intermediate, but now, in this case, instead of attacking with bromide, I'm going to attack with water. And same thing, opposite to the opposite side, this will open, so the opposite, they will end up opposite sides. So if I attack, in this case with water, I'm gonna draw, well, initially you will have this with a positive charge. This will open up and you will get bromine here. Remember that in that carbon we had an ethyl, so still here. But final, after removing the proton, I am going to get the alcohol group here, OH, ethyl, and bromine. But I also, remember again, we will have the enantiomer. So again, what had changed in the two reactions? The nucleophile. They both go through the same intermediate, and every time of forming those intermediates, cyclic like that, the attack is on the more substituted carbon. This is a lot of ring strain, so it will open, and it will open opposite. So you end up with, notice the final position of the, say, nucleophile and the bromide. They're opposite sides, so it is anti. Both reactions are that way. But here we have a different nucleophilic attack. But this is opposite sides, okay? So we will do more problems revisiting and reviewing, contrasting and predicting products of alkene reactions.